Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. And if you need global distributions, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/Linode, that's Linode today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of this show. You listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Cunningham Global Intelligence, Alluxio, and Data Council. Go to dataengineeringpodcast.com/conferences to learn more about these and other events, and take advantage of our partner discounts to save money when you register today. Your host is Tobias Macy, and today I'm interviewing Ted Kaemming and James Cunningham about Snuba, the new open-source search service at Sentry implemented on top of Clickhouse. So, Ted, can you start by introducing yourself?
Hey, my name is Ted Kaemming. I am a software engineer here at Sentry. I work on the search and storage team, which is responsible for, as the name would imply, search and storage. A lot of that happens through Clickhouse these days.
And James, how about yourself?
Yeah, like you said, my name is still James Cunningham. I manage the search and storage team. I also manage engineering operations. I was the first operations engineer to deploy and maintain our ClickHouse clusters. So, good person to talk to.
And so going back to you, Ted, do you remember how you first got involved in the area of data management?
It's something where, previous to Sentry, I worked at a company called Discuss. At that company, we had a lot of reads compared to Sentry, which is incredibly write heavy. I worked also on an infrastructure team there as well, mostly dealing with shuttling data around as you do in kind of any web application. So I don't know if I necessarily characterize myself as someone who has really focused on data management as a specific career path or anything like that, but it seems like on any web application, the shared state for that application is so critical to that application's functioning that everybody kind of trends in that direction. The more these things scale. So through my career, I just spent a lot of time interacting with databases, and you get to know them fairly well through that process, I guess.
Yeah, I'm familiar with that. It sort of follows you around as much as you try to run away.
Yeah, for sure. Yeah, everything eventually will talk to the database, it seems like.
And James, how about you? Do you remember how you first got involved in the area of data management?
I did. Before I met the wonderful people at Sentry, I used to work at a place called Urban Airship that's currently known as Airship. We had a non-trivial amount of HBase clusters, the open source implementation of Google Bigtable. And I was privileged enough to kind of work alongside those. And I said, wow, these are kind of pretty cool. We paired that a lot with Postgres. Sentry ran Postgres. I actually operated Sentry at UA. Then I came over here because I had direct experience. And when we kind of started moving away from being a Postgres shop, I said, aha, it's my time to kind of dig back into my brain about how non-row storage kind of worked. And ever since then, I've been loving this and kind of hating Postgres. So doing pretty well.
We still like Postgres, don't we?
Yeah, so I know that when I interviewed Dave Kramer on my other podcast about Sentry and some of the early days of that, he was mentioning that at least for a while, the overall data infrastructure was running entirely on Postgres and didn't use Elasticsearch or anything, just used some of the full text indexing on Postgres for being able to handle searching across the event data. So I'm wondering if you can just start by describing some of the stresses and pain points that you are running into on the existing infrastructure and how that led you to deciding that you needed to re-architect and build this new system.
Yeah. So when I joined, which was pretty early on in Sentry, as a company's history. At that point, when events come into Sentry, they are basically being written to a collection of different data stores after processing. So we kind of logically split that up into 4 different kind of service components, I guess you could call them. There's the time series database that was backed by Redis at the time. Primarily, that was just counters bucketed by a time granularity. We also had some sketches, hyperlog logs, stuff like that in there to get unique counts. So TSDB was one. Another one was this thing called tag store. Tag store was basically just an abstraction we had around dealing with denormalized data for like the tag key value pairs that come along with an event. So that was in Postgres, started off on the same Postgres database as everything else, eventually got split off into its own database, and then we eventually had to shard those tables across a larger cluster. Then also another logical component was the search backend. The search backend was really just Postgres. I don't think we ever actually had Elasticsearch running for anything, at least during my history here in production. So the search backend was, like you mentioned, just running SQL queries over these tables. That, as you can probably imagine, when those tables became physically separated onto different hosts, got more complicated. And then the 4th place that event data ended up in is a abstraction called Node Store. Node Store at the time was running on React from Basho, which has since kind of been EOL'd. As Sentry, though, is an open source product as well. All of these things had different pluggable backends. So other people who are running Sentry and their own infrastructure, they could run it just using Postgres. Again, they could use it running Cassandra. These days we run it using Bigtable. So we had all this data split into these 4 different storage systems that was all basically derivations of the same input data. Those writes generally happened via Celery, so a kind of task abstraction written in Python. Most of Sentry is Python. We're big fans of Python, honestly. We've been able to make it work for our load. But since this is all kind of going through Celery and we're using Rabbit at the time as the message broker, we're just mutating single rows at a time. That became a performance pain point. Some of that ended up in a situation where we were buffering these writes, so increments to these counters, things like that, through this kind of buffering system that we built in Redis, and would apply bulk updates to those denormalized tables. So basically, we just had a bunch of different data systems laying around, managing different lenses of looking at the same actual input data. So it got particularly complicated.
And were you starting to run into any user-facing problems, or was most of the pain just in terms of the internal operations and trying to deal with managing the data and the cognitive load on the engineering side?
There's definitely there was both kind of that internal pain as well as the user-facing pain. I think really a lot of the user-facing pain was just manifestations of the internal pain. So internally, like you mentioned, there's all this operational complexity with running all these different systems. There's just tons of points of failure. Scaling with the data volume was an issue. Also, the code complexity. All those things eventually become user problems because the operational complexity of having all these single points of failure, that affects the user experience when those single points of failure fail. And, if someone can't look at their data on Sentry, the code complexity manifests itself in the fact that we're not able to iterate and build new features as quickly as we'd like. Along with that, there was a bunch of other stuff with consistency problems because all of these systems are ingesting at different rates, or this buffering system sometimes would back up. And so you would see these denormalizations that hadn't been updated in potentially several minutes in worst cases. Those kinds of things would obviously affect the user experience. When those things affect the user experience, They write into support. That means an engineer is having to investigate what's going on. All of a sudden, the engineer can't make forward progress on improving these things because we're busy, diagnosing and explaining this sort of idiosyncratic behavior. Overall, things just kind of slow down from there. So yeah, it was both internal and I think as well externally, just not what we would have liked to present in an idealized situation.
Yeah, especially given that your product is used in such a way that people want to be notified in a timely fashion and potentially need near real-time capabilities because it could be affecting their customers. So definitely a lot of cascading errors that can propagate from what seems like a simple tech debt problem to something that eventually explodes into something that, like you said, grinds everything to a halt. And so that finally catalyzed you into deciding that you needed to redesign and rebuild these capabilities. And I'm curious what your design and operational criteria were for determining what needed to go into building this new platform.
Yeah, so I'd say as far as all the decisions that we made in order to go into this new platform, one of the biggest leaders was that when we had a big push for having environments be kind of like a first-class filtration, we had to build a new dimensionality of data across all this denormalized data. We essentially doubled the storage that we had. And then we said to ourselves, oh, this is great. This looks cool. Environments are dope. But what happens when we want to add another dimension and another dimension? Are we just going to continue to, extrapolate across this data set and eventually end up with 100 terabytes of, 5 different dimensions of data? So we said to ourselves that we kind of needed a flat event model that we'd be able to kind of search across. And to ourselves, there are a few other pieces that we wanted on top of that. We wanted to be able to search across some of these arbitrary fields that we really, really looked into, whether those are custom tags or something that we kind of promote, whether that is releases or traces or searching across messages. We didn't want that to take as long as it did. And some of the other parts is that we have all of this data stored in this tag store and all these searches that we have to go through, but we have a completely different side for time series data that, again, had to have that dimensionality in it. If we searched across these arbitrary fields, the next thing that a customer would ask for is, hey, could I please see a pretty graph? So if we could boil down that search and that time series data into the same system, we'd be destroying two systems with one rewrite.
And also, as part of that process, you kind of always have the standard checkpoints, the replication and durability is obviously really important for us. Ease of maintenance is huge. Low cost as well for us. So even that just kind of ruled out some the hosted magic storage solutions. Those kinds of criteria as well apply.
And as you were deciding how to architect this new system, can you talk through some of the initial list of possible components that you were evaluating and what the process was for determining whether something was going to stay or go in the final write?
Yeah, of course. So our first, thing that we kind of crossed off is no more row orientation. Postgres has served us well. Probably wouldn't, we hoped that we could engineer a good solution on top of it, but ultimately we decided we probably needed a different shape of data to be able to query across. We've kind of had 5 major options. We had document stores. We had some sort of Google proprietary blend because we are completely on GCP. We had, more generic distributed query stuff, a little bit of Spark, maybe a little bit of Presto. We took a look at other distributed databases. We ran a good amount of Cassandra at my old gig, so I know how to run that. And then we also said oh, hey, we could just put data down on disks ourselves and not have to worry about this. Some of the other serious considered things that we had was a column restore. Some of these other ones that we actually kicked the tires on was Kudu. We kicked the tires on Pinot and Druid. And ultimately we found Clickhouse as a column restore. And we kind of just started running it. And it was one of the easiest ones to kick the tires on. Some of these other column restores built on top of distributed file systems, it really did take a good amount of bricks to put down in order to get to your first query. And some of the things that we wanted was figuring out operational costs on that. We wanted to be able to iterate across it quickly. We wanted to be able to kind of pare down on the dependencies that this service had. while we weren't afraid to run a few JVMs or to run a little bit of HDFS, that was something that realistically I might not want to have an entire engineer dedicated to running something like that. And on the antithesis of that, we could choose some of this Google proprietary blend, but how would it feel to go from having Sentry only require Redis and Postgres to now saying you can only run the new version on Google?
Yeah.
That was a little bit silly. So we ended up really just getting through an MVP of, I think, both Kudu and Clickhouse. Okay. And one of the biggest ones that really did kick us, and for anyone listening, go ahead and correct me if I'm wrong, but one of my memories was that one of our engineers, started loading data into Kudu, and you didn't really know when it was there. It was great for being able to crunch down a bunch of numbers, but one of our biggest things that you did kind of hint at is that we do need real-time data, and to be able to write into this data store and then to be able to read it on a consistent basis was one of the things we needed. We have the ability to have a feature called alert rules in which you say, hey, only tell me if, any event with the tag, Fuman got in and the value equals true, which was only maybe like 10 events in the last hour. And you want to be able to read that pretty quickly so that when that 10th event comes in, you're not waiting minutes until that alert shows up. And Clickhouse was able to do that. And so that kind of just got its way up to number one.
Yeah. I think also in general, like at Sentry, we try and kind of bias a little bit towards relatively simple solutions. And it seemed like Clickhouse, there was, at least to us, based on our backgrounds, it seemed more straightforward to get running. And I think that as well appealed to us quite a bit. The documentation is pretty solid. It's also open source. A lot of these will be, but Clickhouse has a pretty active repository. They've been very responsive when we've had questions or issues. They're very public about their development plan. So I think a lot of these things just kind of worked out in its favor.
Yeah, it's definitely, from what I've been able to understand, a fairly new entrant into the overall database and data storage market, but I've heard of a few different stories of people using it in fairly high load environments. So I heard about the work that you're doing with Snuba. As far as I understand, Cloudflare is also using it for some of their use cases, and they definitely operate at some pretty massive scale with high data volumes. So it seems like a pretty impressive system that has a lot of different capabilities. And I was pretty impressed when I had some of the folks from Altinity on the podcast a while ago to talk about their experience of working it and working with some of their clients on getting it deployed. And I'm curious what some of the other types of systems you were able to replace with Clickhouse were, given that you, as you said, you have these 4 different systems that you had to be able to replicate event data to. Were you able to collapse them all down into this one storage engine?
Yeah. So like in our code base, those 4 different things, the TSDB, search, tag store, and node star, all have kind of abstract service interfaces that really just sort of evolved from the fact that it's an open source project. People wanted to use these different backends for it. 3 of those now are backed by the same data set in Clickhouse. So all the TSDB data comes directly out of Clickhouse. There's no pre-aggregation that happens anymore. It's just, we're just ripping over individual rows, computing those aggregates on demand, at least for now. Search, some of the data for search still lives in Postgres, but a lot of it now is it just runs from log data in Clickhouse, essentially. Tag store, we've removed how many servers were we using for tags?
We had, like 12 N1 HiMem 32s, which is a 32 core, and maybe 200 odd gigs. But, getting into some of these other stats that we have a little bit more down the list, we went from 52 terabytes of SSDs to 2 terabytes. Which is a good number to bake down from.
Yeah. So we were able to...
Yeah, absolutely.
Yeah, we were able to decommission like an entire Redis cluster, like cluster in quotes, and this entire Postgres cluster with drastically less hardware. And yeah, just the fact that it all reads from the same Clickhouse cluster and there's none of this weird replication lag between all these systems, it's a huge positive.
Can you talk a bit more about the overall architecture of Snuba itself and just some of the operational characteristics and experience that you've had in terms of ClickHouse itself and maybe some of the early pain points and sharp edges that you ran into as you were getting used to this new system?
Yeah, sure. So I guess just to give you kind of a brief overview of the architecture, because it's something that's really not particularly fancy. It's really Snuba is just a small, relatively small Flask application, at least small when you compare it with like the remainder of Sentry. So it's a Flask application. It just speaks HTTP. It's in Python. It's generally stateless. The writes as they come in, they go through a Kafka topic. It's published directly from the remainder of the Sentry codebase. The Sentry codebase and the Snuba codebase are actually completely independent, at least as far as like the project Git tree. So Sentry writes in this Kafka topic. The Snuba consumer picks them up, does some denormalization, some data munging, kind of conventional Kafka consumer stuff, and writes large batches of events to ClickHouse. We don't use the ClickHouse Kafka engine or anything particularly special for that. We just use the Confluent Kafka driver from Confluent, which is libarty Kafka based, and that's all in Python. Reads to Snuba happen also over HTTP. Not anything also particularly fancy there. We have some various optimizations that we do, kind of just a general query cache and deduplication of queries, so that way we don't have large queries that have long runtimes executing concurrently on the cluster. We do some optimizations where we move some stuff from the where clause in ClickHouse SQL to a pre-where clause, which is basically the closest thing you get to any sort of query optimization. And we do some other just like query rewriting stuff based on our domain model. There's other rate limits and quality of service, metrics logging type stuff that happens in there as well. As long as that all goes well, a response is returned to the caller with something that is almost identical to what you would get if you were just interacting with the HTTP interface of ClickHouse itself. If it doesn't go well, that ends up getting logged to Sentry, and we we then kind of enter the system again to go look at it. So that's kind of the brief overview. It's nothing particularly fancy.
Yeah, sometimes simple is best, particularly when you're dealing with something that's as critical path as this.
Yeah, for sure.
Yeah, so towards a little bit of the early engineering that you might have alluded to, one of our biggest early difficulties was that we've spent a lot of eggs in the Postgres basket. So we turn this on and, the queries that we'd set up for a row-oriented database are just like absolutely not meant for a column restore, which is a crazy thing to say out loud.
It's so easy to type select star, though.
So easy. Spelling is hard. But, there's some things that just absolutely did not cut over to this column restore that we kind of had to like redesign how we had every query. Sentry kind of had a quick application of order by some arbitrary column and then limit by 1,000 to be able to like explicitly hit a binary tree index in Postgres. And that didn't matter in ClickHouse. Any sort of limits just kind of truncated what rows you were returning. If you applied an order by, that would have taken your entire data set and ordered it. Some of the other things is that we had a lot of select stars everywhere, like Ted said, and that is honestly one of the worst ways to operate on a column restore because you're just reading from every literal file. So we had to change that a little bit. Some of the other things that we kind of had, we didn't have a query planner. So there was a lot of like taking a query and just kind of moving pieces around. One of the things that Ted alluded to was the notion of a pre-where. When you have, multiple columns that you want to filter on in a where clause, you kind of have the ability to give ClickHouse a little bit of heuristics and say, this is the column that we believe has the highest selectivity. And if you put it down in a pre-where clause, it will read through that column first, decide which block IDs it's going to read from for the rest of them. So if you have something along the lines of an event ID that for us is, globally unique, that might have a little bit higher of a selectivity than an environment, or, a release might have a little bit of higher selectivity. So we were kind of working around these edges by just swapping variables around and saying, well, did that make it faster? And then if we said yes, we kind of threw some high fives around.
Yeah, they're like also just the integration into some of the query patterns we have in Sentry was a bit of a challenge. Clickhouse is really designed to do particularly well with inserts. It does not do particularly well with updates or deletes to the point where they aren't actually like syntactically valid in the like Clickhouse flavored SQL. So we had like Sentry as a whole is particularly insert heavy, but it's not insert only. And so we had to kind of work around basically the fact that Clickhouse is extremely oriented towards inserts. We kind of ended up with something that actually James mentioned he worked on Cassandra in a past life. I did as well. We ended up with a architecture that is fairly similar to the Cassandra tombstone for how we delete data, where we kind of implement our own last right win semantics on top of the replacing merge tree in Clickhouse. There's a long blog post about how we do that as part of, we have this field guide series that we've been working on where we go into some of these like weird things that we do with Clickhouse. Similarly, for things like those alerts that James mentioned earlier, we basically require sequential consistency to be able to execute those queries effectively. That becomes a problem when you're dealing with multi-master replication like Clickhouse does. So we ended up having to do some kind of dodgy load balancing stuff where we don't have a literal primary for all writes, but we kind of have this ad hoc primary that all writes go to as long as that is up. And for some subset of queries, they are only allowed to evaluate on that primary. It's not like guaranteed sequential consistency in like a true distributed system sense, but it's good enough for what we need. It's also particularly complicated because the system doing the querying is not Snuba. It lives in the Sentry code base. And so we basically need to be able to notify the Sentry code base that these rows have been written to Clickhouse from Snuba as part of this. So we ended up having to engineer this solution where we have a commit log coming out of the Snuba Kafka consumer that the Sentry application is actually subscribed to that Kafka topic, the commit log Kafka topic, and gating its own progress based on the progress of the Snuba writer. There's also a blog post that goes into more depth about how we specifically implemented that on the Sentry blog as part of this field guide series. But just, yeah, things like that you, like we knew things like the mutations were going to be something that we had to manage. We didn't particularly have strategy around it. And the sequential consistency stuff probably caught us a little bit more by surprise than it should have as we were doing some of our kind of integration testing in production with this and noticed that some of the queries weren't exactly returning what we thought they would have. And so that was something we also had to solve.
And you mentioned that one of the reasons that you ended up going further forward with Clickhouse than any of the other systems is that it was pretty easy to get up and running with and seemed fairly simple operationally. So I'm curious what you have found to be the case now that you're actually using it in production and putting it under heavier load and in a clustered environment, and any sort of useful lessons that you've learned in the process that you think anybody else who's evaluating Clickhouse should know about.
Absolutely. So this is my time to shine. So one of the things that I kind of had to make a concession to is that I've never worked with a database that could possibly be bound by CPU. It's always been, make sure that your disks are as fast as possible. The data is on the disks. You got to read from the disks. And the reason that, it very well could be bound by CPU is that, I've seen compression in the past, and I didn't really understand what compression could actually give you until we turned Clickhouse on. Sorted compression, realistically, brings our entire data set, we kind of alluded to it earlier, brings our entire data set from 52 terabytes down to 2 terabytes. And about 800 gigs of those are surprisingly uncompressible because they're unique, 32 character strings. If anyone can tell me an algorithm that helps compress that. I think that we made a television series around that or something like that. But for the rest of the data, it's so well compressed that being able to actually like compute across it does so well. We run a small amount of servers to supply what is a large amount of a data set. We started, I would say that like if there was any advice to anyone out there, start by sharding. Never shard by 2 because 2 is a cursed number in terms of distributed systems. But we really just started with 3 shards, 3 replicas, and with that blessed number of 9, we haven't gone up yet. We kind of have a high watermark of a terabyte per machine. Google gives a certain amount of read and write off of that disk based on how much storage you have. And we've kind of unlocked a certain level. And 1 terabyte for a machine on, if anyone else is somehow running ClickHouse on GCP, or I guess on GCE, that is, we're about to apply our 4th shard. But realistically, some of the other things that are operationally sound is that, as much as we'd all love to, I guess, like hammer on or praise XML, it is very explicit about what you have to write in. It's configured via XML. There's no runtime configuration that you're applying. There's no, magic distribution of writing into an options store and watching that cascade into a cluster.
You're not auto scaling.
Yeah, I'm not, crunching in any Kubernetes pods or anything like that. One of the things that I'd be remiss to not say is that you did mention Cloudflare is running ClickHouse, and shout out Cloudflare. They run real hardware, and I'll never do that again in my life. But one of the things that they alluded to in one of their kick-ass blogs about ClickHouse is that it replicates so fast that they found it more performant that when a disk in a like RAID 10 dies, they just wipe all the data, rebuild the disk essentially empty, and just have ClickHouse refill it itself. It is crazy fast in terms of replication. Since all of that is compressed, it really just sends that across the wire. Some of the other stuff that we've found completely great in terms of operational wise is that since it is CPU bound, it's mostly by reads. When you are a write heavy company and you're now bound by reads in terms of cost of goods sold, like I can throw around a million high fives after that. It's great to just watch people log in and actually look at their data and watch our graphs tick up instead of just saying, well, we spent a lot of money on this and people are only reading 1% of their data. One other piece that I'd be remiss to not answer is that some niceties about ClickHouse that kind of separated it from a few other databases that I've worked with is that you have the ability to kind of set some very quick, either like throttling or kind of like turboing settings that you have on a client side. So some of the things that we might do is that if we know that a query is going to be expensive, we could, sacrifice a little bit of resources and to kind of like turn it back fast. So there is just a literal setting that is max threads where I say, you know what? I really want this to run faster. Set max threads to 8 instead of 4. And it does exactly what it says it does. It'll run twice as fast if you give it twice as many threads. So there are pretty easy things that we kind of run around in terms of operational wise. I think that as far as a database goes, one of the hardest things to do is just kind of read all of the settings to figure out what they do. But after you kind of get versed in it, you'll understand, what applying this setting might be or at what threshold you might set something. And it's not very magical. Some of these settings realistically are for very explicit types of queries that you'd only supply from a client side if you really needed them. So fairly, I wouldn't go so far as to say simple, like the configuration's almost like dumb in that it's
very straightforward.
Very straightforward. Yeah.
And my understanding is that ClickHouse itself is written in C, so it runs very close to the metal on the instances that it's running on, but that for clustering, it relies on Zookeeper, which, as you mentioned, the JVM processes. And so since you're already running Kafka, I imagine that you already have a Zookeeper cluster for that. So I'm curious if you've been able to just use that same Zookeeper cluster in sort of a multi-tenant fashion to service both Kafka and ClickHouse, or if you built a dedicated Zookeeper cluster or Zookeeper node for the ClickHouse databases on their own.
Solid question. Kind of a two-part answer here. Realistic for Kafka, I have a long-winded story about going from Kafka like pre-082 to post-082 or 084, whenever they introduced store and consumer offsets inside of Kafka itself. After that, Zookeeper is really only a dependency for like hello, you are consumer one, you have control over these partitions, and, leader election and all that strong consistency stuff. But realistically, if you had some IoT toasters, you could throw down a Kafka Zookeeper on that. So we bundle those alongside, I guess like physically co-located with the Kafkas that are running. We have the Zookeeper. And one of the other things I kind of learned from managing Zookeeper at my old gig is that if you have the opportunity, you really don't want to mix things in terms of multi-tenancy for Zookeeper. And a strongly consistent system, if for some reason that's breaking down, you don't want it to push that load to someone else. So Zookeeper for Clickhouse, it is dependent on who has received which block and where to get that from. So it's kind of used for the way that replication is designed. It's also kind of helpful for, I guess, a setting that they have that is select sequential consistency, which actually didn't work out too well for us. But it is one of those ideas that if you want to read this block, you can block on whether or not all of the replicas have gotten them. So they kind of use Zookeeper as that consistent state for which blocks live where did this write go to? If I want to get this right, which server should I reach out from? So, in terms of gossip, in terms of adding more replicas, realistically, not that much pressure gets applied to Zookeeper. But it is physically and logically segmented just because that's kind of one of those like tinfoil hats that I wear around here.
Yeah, working in operations, it's definitely always the better safe than sorry approach, because as soon as you're not safe, you're definitely going to be sorry.
Absolutely. Yeah. Well, there's a question that I don't really like answering, which is, oh, hey, why is Kafka backing up? Oh, well, that's because ClickHouse is doing something wrong. And someone turns around to me and be, why in God's name did these two systems not know about each other but are negatively impacting each other?
Absolutely. Shared nothing.
Yes.
Sort of our disaster scenario is like ClickHouse goes, completely offline and the Zookeeper cluster would be trashed. In this case, at least our Kafka cluster is still running and just queuing up writes that we can hopefully, when we recover, write to. Like, God forbid that happens, but at least if it does, there's some amount of...
This runner board's made out of wood.
There's some amount of insulation from that.
One of the other interesting pieces to discuss is because of the fact that you already had a running system, you already had this large volume of data, as you mentioned a couple of times, the 52 terabytes worth of events. What was your process for introducing ClickHouse and Snuba into that architecture and replicating the existing data into it while still maintaining uptime and still servicing end user requests so that they didn't notice that cutover in the introduction of this new system, except in a positive sense?
Yeah, that's a good question. So I think this entire process from start to like being at 100% live probably took roughly a year, give or take a few months.
A month or two.
And during that process, I don't recall that we had any outages related to this or any downtime, like not even outages, like planned maintenance related to this as well, which is kind of wild. Because like we talked earlier, people use Sentry to monitor their applications. If the monitor is down, that doesn't reflect particularly well on our quality of service and also leaves all of our customers in the dark. So what we ended up doing is we were both dual writing as well as dual reading to those legacy systems that we discussed earlier, Redis, Postgres, all these other things. We were writing to those, reading from those, while we were spinning up the new Snuba/ClickHouse cluster. So we were doing that for probably months towards the tail end of this process. With that, what we were doing, and I don't think this is a particularly novel approach, but it does seem like it's something that not many people talk about, at least from what I've seen. Maybe that's just people consider this aspect less interesting than talking about the shiny new tech. But earlier, we talked about having these sort of abstract service interfaces, which came from just the flexibility of it being an open source project. We built this thing called the service delegator, which basically delegated requests to these services in the background. So we could run a request against the TSDB, and we could run against the legacy system as the primary, And in another thread, we'd also execute that same request against Snuba. It would wait for both of those requests to complete. Then it would shovel a bunch of data into Kafka that we would actually then do some analysis on and write back to a different ClickHouse cluster where we'd then do analysis on that to figure out essentially how similar the results from both of these systems were. So this allowed us to test, different schemas on the ClickHouse side. We tuned a bunch of settings. There's basically no risk with that because worst case scenario, the ClickHouse cluster would back up on load. We would just turn the switch down, let it drain, and change that configuration setting again and spin the reads up in the background and figure out if that solved the issue. So we went through a bunch of different iterations on the schema, on all these configuration parameters to figure out basically what was the best fit for our needs. This also allowed us to get a lot of operational experience in production without the fear of any sort of like user-facing incident or outage. There were a few hiccups. We learned definitely some stuff operationally along the way that had this just been something where we had the like light switch analogy where we just go like, well, we think we tested this really well. The test suite passes. Let's flip it and see what happens. I think we probably would have had some fairly embarrassing results coming out of that. So yeah, there was a lot of just kind of plotting of these similarity scores between these different backends, identifying these inconsistencies, like the sequential reads that I mentioned earlier showed up as part of this process where we realized there was this sort of interesting distribution when we were looking at the results from our time series database. Basically, the output that we were seeing when we plotted these similarity scores, which were normalized from basically like a 0 to 1, we'd see this bimodal distribution where there were roughly half of the results that were exactly the same and roughly half that were not at all the same. And took some digging to figure that out and realized that was because this automated system was making a request as soon as it thought that the request had been persisted, but it had been persisted to the legacy systems and it hadn't actually made it all the way through the Kafka pipeline, so to speak, into ClickHouse. And so it was issuing requests against ClickHouse that either weren't on the server it was requesting them from, or that just hadn't even made it all the way through the processing pipeline yet. So that's also something that we wrote a particularly long-winded blog post about as part of this field guide series, and it kind of walks through that process in a little bit more detail. But basically, by the end of it, we had been running for a couple weeks, I think, at 100%, both the old system as well as the new system. We had all this consistency monitoring in place. We hadn't seen anything particularly aberrant, and we just basically, cut over from the secondary to the primary, and some queries got a little bit faster, but otherwise it was essentially a non-event at that point, which is probably the most relaxing launch that I've had of like anything in my career, I think.
Yeah, that's definitely always a good experience.
Yeah, it was very low stress, which doesn't always happen in kind of like infrastructure engineering land.
And now that you have cut over to using Snuba and ClickHouse and you're storing all of your event data in this new storage layer, what have you found to be some of the downstream effects of being able to have this greater reliability and consistency? And what are some of the other consuming systems that have started to leverage ClickHouse and the data that you've stored there for different purposes that were either previously impractical or impossible?
Yeah, so realistically, we set out to replace these systems, but in the background said, all right, like, now that we've moved into the new house, can we start building some shiny things on top of it? So all of the products that we launch, again, shout out to our blog, pretty easy now. All of them are, any graph that you might see, any search, any filter, any sort, that's all powered by Snoop and ClickHouse. So all of the features that we're developing for greater data visibility, all of those are powered by this new search system that could not have existed previously. Some of the other more like infrastructure benefits that we've kind of seen is that deleting event-driven data from Postgres was a pretty easy query on paper, where you just say, delete where timestamp is greater than retention. And that's great when you don't have to do any child deletions. You might be able to do some bulk. But if we're deleting individual events one by one, we are literally doubling the amount of commits that and the amount of transactions, the amount of walls that we're writing to this Postgres machine, just to be able to not run out of space and to make sure that we actually delete our customers' data when we said we would. So now in ClickHouse, since it's a columnar-oriented storage, we, I guess, like physically segment all of these files across weeks. And once one of these segments roll out of retention, we just delete the folder. A running drop partition takes seconds, and it just is an unlink, and it's one of the easiest things we've ever done. It is a great thing to say, hey, what happened to the data? It's like, oh, it got deleted. No notice. It's fine. One of the other pieces with resilience is that whenever we wanted to upgrade some of these other machines, whether that be, Redis or Postgres or even React, upgrading processes were a very long amount of time for operations. We would all get into the same room. We'd have task plans. They would be, checking off these boxes, shuffling these tiles over here, turning this off, turning that on, crossing your fingers. PG bouncer's good. All right, we're good. But with ClickHouse, when we have these, 3x3 shards, realistically, all we're doing is just saying, all right, bump the version, restart it. All right, it looks cool on this machine, push it to the other 8. There have been times where we've rolled back because of, maybe various settings that we missed to set, maybe something that might have been baked into a default that realistically shouldn't have been. I think in my time of upgrading, I've probably upgraded about 12 times to whatever releases they've cut. And I think maybe like 3 or 4 of those have been rolled back. But it's really just, whoops, that didn't work. And nobody noticed. Well, hopefully nobody noticed. I kind of saved that for maybe a Saturday or a Sunday because our traffic's pretty US cyclical. So if you're using Sentry on the weekends, I don't know, go back to watching TV. But realistically, in terms of our downstream benefits, like it's the compression, it's all the ease of operation. Realistically, it's just something that we don't babysit that much anymore.
Yeah, I think like anecdotally, the support load on like why is this system doing something weird has gone down. Like the data stores don't get out of sync in the same way they could previously. Data comes through in a more timely fashion. So there's no, hey, why does this count not match this other count? Because all the counts now come from the same spot. It's also something where I think ClickHouse has kind of snuck into some different places of our internal systems as well. All like the requests that come through Sentry, both from the load balancer, as well as all of the results of essentially every request that hits our application servers also now goes into ClickHouse, which is something we had always talked about. When someone writes in and says, hey, I have this UUID, what happened? We can actually give them an answer without just like grepping through tons of log files or just saying, well, it looks like there's a lot of rate limited activity, so probably happened over there. We can actually give them a conclusive answer. So it's definitely something that we're getting a lot of mileage out of, and we're finding new uses for it routinely.
And the Snuba system itself, it is an open source project. Is it something that is potentially useful outside of the context of Sentry, where somebody might be able to adapt it to different search implementations, or is it something that's fairly closely linked to the way that the Sentry application is using it, and it wouldn't really be worth spending the time on trying to replicate the functionality for a different backend or for a different consumer?
Yeah, that's a really good question. So as of literally today, it historically has been extremely coupled to our domain model. It is less coupled to our domain model today, but it's still pretty coupled to our domain model, unfortunately. Most of the work that has gone into it has been motivated by our product needs. So a lot of the early internals are pretty closely coupled to those original goals, really just as a function of trying to get it out as quickly as possible so we could stop turning on Postgres servers and dealing with Postgres query planner related outages or transaction wraparound, those kinds of just like scary nightmare things. So it's originally pretty coupled to the original data model. That data model, though, is evolving. We're adding new data sets in the ClickHouse. Like I mentioned, those event outcomes that get logged into it. So Internally, there's a lot of that refactoring happening to reduce coupling. I think sort of the logical end state of that is something that is more abstract, but as it is right now, to add a new data set is sort of our analogous concept to table. You essentially have to fork the project. All the DDL happens in code. We'd love for that to be sort of more declarative, whether that happens via configuration or some other means where you're not getting in there writing Python and like literally editing the project. That would be, I think, where we'd like to see it go. Also right now, the code is pretty stable. Documentation is definitely a work in progress. So that's something I think for anyone who wanted to experiment with it, we need to invest more time in making it easier to do that. The code itself, though, is obviously it's on GitHub. Anybody is free to browse around, take a look at it. We do welcome contributions. Though right now the barrier to entry is definitely higher than we would like it to be in the long term, I think.
Are there any other upcoming new projects or any other major data challenges that you're facing at Sentry that are either causing enough pain that you need to do a major refactor, or anything that is forward-looking that you're able to spend time and focus on now that you've freed yourself from the burden of trying to maintain these multiple different systems and their lagging consistency?
Yeah, solid question. So we really did just, as Ted said, cut over from that a data set that we call outcomes for all the data that is in this main Clickhouse cluster. Those are all accepted events, but we have a certain amount of outcomes that do happen. We have an event that might be filtered, an event that might be dropped due to a configure rate limit, or if someone has gone over their project quota. We have invalid events as well. We have a pretty substantial abuse here from people that just keep sending us events, even though we told them to stop. And all of those counts used to go into kind of the same TSDB model for all of the other dimensions that we had. And honestly, I think just this Tuesday, we finally stopped writing about 300,000 increments a second into that data set for Redis. And it's been all being written into Snuba at this point. Moving forward, yes, we can't give away the full product roadmap, but we've had a lot of draws from the idea tank and say what happens if Sentry starts storing more than errors and crashes, and all of Clickhouse is kind of centered around that at this point. So doing a good amount of internal testing. If anybody wants to read some source code changes, they could probably learn a little bit more about that. But I guess good luck on that reading. We do okay at documenting our pull requests and what they're about, but there's a lot of chatter on internal lines that someone might not have a lot of full context on. But
yeah, you could read between the lines and figure out where things are going. So we're not particularly hiding anything, even though we might be a little bit cagey about it. Yeah. One of the other things that's sort of like a challenge moving forward beyond just like new types of data is, so I mentioned the search backend before, and how the search backend was basically querying a bunch of different Postgres tables. Those tables eventually started to live in different databases, and joining across those databases is hard. That's still basically a problem that exists today, except now rather than joining between a Postgres on one host and a Postgres table on another host, we're joining between a Postgres table on one host and Clickhouse, on a completely different cluster. So one of the things that we've been experimenting with is implementing a change data capture pipeline, essentially replicating our data from Postgres via the logical decoding interfaces and writing it through Kafka into Clickhouse. And so Clickhouse would actually act as a read replica for this data that exists in Postgres. We haven't really tested any sort of complex join clauses yet. So we're going to kind of see what happens with that. But ideally, if we can have these cross-database joins effectively not be cross-database and have that data be co-located, potentially the compression works so effectively, and the subset of data that we have in Postgres that we need to join on is so small that we can probably have full replicas of these Postgres tables that are used in search on literally every Clickhouse node. So it'd be a local join on all these servers, which would be wildly better than passing around large sets of IDs like we have to do in some cases now. So that's definitely something that is kind of on the roadmap that we are looking to figure out. That also, in accordance with sort of our general philosophy, that's going to be available on GitHub for people to experiment with on their own as well.
Are there any other aspects of your work on Snuba and using Clickhouse and just the broader context of search and storage at Sentry that we didn't discuss yet that you'd like to cover before we close out the show?
Shameless plug, we're hiring. If anything sounded interesting, like, find me on the internet. But that's about it, man.
I guess one thing that we didn't really talk about with like future work is right now as a product, Sentry basically provides a lot of it gives you access to a lot of data, but it doesn't kind of there's no opinionated insight that comes along with that. So, there's definitely value in like opening Sentry, looking at your issue stream and seeing that a thing is particularly bad relative to history or whatever. That doesn't give you any sort of qualitative information about like if this number goes up, does that mean this thing is bad? Or there's basically a whole lot of context that's missing there. So one of the things that we've been talking about is trying to like supply more context as well. But at least as far as the search and storage team, like beyond just the rote acts of like literally searching and storing, I think the ability to get more insight from the data is something that is kind of on our roadmap that we're going to be tackling, because now the data is where it needs to be able to do more interesting stuff with it.
I think an analogy that we kind of have with Sentry right now is if you were to walk into an American diner and get like a 10-page menu, and the waiter walks up and says, "Hey, how you doing?" You say, "Oh, what's good here?" And then he goes, "Everything's good." You're like, you sure? So hopefully we can stop searching and storing and maybe start suggesting in the near future.
All right. Well, for anybody who wants to get in touch with either of you and follow along with the work that you're doing, I'll have you each add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today. I'll start with you, James.
It is very difficult to scale up from someone's individual laptop kicking the tires on a database to what very well could be a production shape. There are literal teams that might be dedicated at a company that just have the ability to assess the impact of someone's query that they're writing. How can we go from a laptop and say, that's bad, that's blessed? So right now, I think one of the largest gaps in terms of tooling is being able to assess impact from going from a single SSD to what might be a data warehouse.
All right. Do you have an answer, Ted?
I think kind of building on James's answer to some extent, the ability for us to have a good understanding of when this particular query is executed, how many resources is this going to take? That historically was something that we had a lot of issues with in Postgres land, because the query planner would do some predictive things. 99.9% of the times it would do the thing that you expected and wanted it to do. The other some percent it wouldn't be. And there, like with Postgres, with Explain, there's a lot of insight about why it chose the particular thing it did, but there was no like kind of general model for being able to say, hey, I think this query will cost too much, like don't run it. I know that there's been some amount of research that's happened around that. I have not directly seen any of it. I think having that sort of cost estimation and being able to do more effective kind of rate limiting based not on just like quantity of queries but cost of queries would be something that would be interesting to see in more of these, I guess I would just say like consumer grade databases. Something like that would be really interesting. With Clickhouse, we have extremely predictable query costs because it's just basically scanning. Like everything is going to be scanning something, and the cost is particularly easy to estimate from there. But as things get more complicated, there's going to be more variance in all these runtimes basically. And it'd be nice if it was something that was a little bit easier to account for in a way other than just the volume of queries.
All right. Well, thank you both for taking the time to join me and share your experience of building and deploying the Snuba system and your experience of working with Clickhouse. It's definitely great to get some of that insider experience and discuss some of the pains and successes that you've gone through. So thank you for all of your time and your efforts on that front, and I hope you enjoy the rest of your day.
Thank
Absolutely.
you.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.